When solving a polynomial inequality algebraically, there's two things that you want to check for first. Make sure that your inequality has 0 isolated on one side and all of the terms and everything else on the other side. And then you want to make sure that that polynomial has been factored. And I say all that because that may happen in a future problem that you're asked to do those parts too. Now, once it's factored, what you want to do is solve the related equality. So where is this polynomial equal to 0? And that's pretty simple once it's factored. We set each factor equal to 0. So x minus 9 equals 0 is true when x is 9. And x plus 8 equals 0 is true when x is negative 8. Next, I would suggest mark those values on an actual number line. The scale is not important, order is, okay? So as long as it's in the correct order, that's fine. What this does is it shows us where the function actually equals 0. You can think of this now as kind of like an x-axis even. These are the places where the function's going to touch the x-axis. And in between these values, these intervals that are created here, the function may be below or above those points on the x-axis. So it has divided our x values into 3 intervals, from negative infinity to negative 8, from negative 8 to 9, and then from 9 to infinity. And you can see I've already got those marked over here as well. The next thing you want to do is test a value within each region. And you get to pick what value you want to test. So let's say, for instance, you pick negative 10. That's a value that falls within this region. Anything you'd like. So test it by placing it into the function. And really, you don't have to worry about the actual numerical answer so much as the sign of the answer. So I know that this expression will be negative, and a negative squared is positive. And I know that this expression, this piece, will be negative, and a positive times a negative is also a negative. So that tells me that for this interval, the sign is negative, and that has been marked here. You want to do that with the other 2 intervals as well. If you can ever pick, like say right here, in this interval, I know 0 falls here. That's usually the simplest value to pick. And then maybe something over here in this value that you could pick that's pretty simple is 10. So test those values next. So what we have for this part is negative, but a negative squared is positive. That's positive. Positive times a positive will be positive. This expression, this piece is positive, squared is positive, that's positive, positive times positive, everything's positive. So now we know the sign of values in each interval. And you may say, well, I only picked 1 point in that interval, but I know that there's no other zeros. So it's not going to be, if 1 point's positive here, all of them have to be positive here. Because I've already selected the actual zeros of the function. So graphically, our function may do something like this. Notice that it has some negative y values, positive. It comes back and touches 0 here. It's positive again over here. Now, when you want to say the solution, you want to come back and make sure that the inequalities condition has been met. So you want the polynomial to be less than 0, and that happens where the sign is negative. So then you state the interval where the sign is negative.